Dear students, just I makes you the welcome for this e-learning class, and for your the attentions, let me clear first that in the last episodes we discussed about the different significant figures, what are the rules to be or the follow, and there are the 7 rules we followed for the determining the significant figures. And now we are going to discuss about the most interesting part of that one, how to round up for the significant figures. As I said that for your the measurement, the number of the digits which are coming, all are not your the significant. By taking that account, we have discussed up to how far it to be or the account, how far it to be or the significant, the instrument through which it is or the measuring. In the measuring instrument, if it is calculate, it is the precision values up to your the 2 decimal places or 3 decimal places, up to that numbers only we are confident, and the numbers up to which we are confident in measuring of your the any measuring values, then that numbers of the digits are called your the significant figures. And today we will discuss about the round off of the significant figures. If that significant figures are to be taken and make some algebra of your the addition, subtraction, multiplication, divisions, then how that significant figures to be or the taken into account, on up to how far we have to proceed, that we will discuss. Next we will start one of the last part of this chapter, that is your the error analysis, and if the time will provide, then we will go for the types of the error. Next we will go for the propagation of the errors. So, let us now come for your the round off of your the significant figures. For the round off of the significant figures, round off the significant figures. So, from which places it to be or the rounded off. Suppose 2.3456, some measurement is given. I want that the significant figure up to your the 3 significant figures, then we have to round off that one. 3 significant figures means 1, 2, 3, means after that it to be or the rounded off. So, if it to be or the rounded off, instead of the taking here the 5, let us say that this is the 7, it to be or the 7, and suppose one is the 2.3446 and 2.3456. So, these 3, suppose 2.340, likewise the examples I given. So, if this is up to your the 3 significant figures we will go, you see 1, 2, 3 significant figures, and from here we have to round up. So, when we have to round up from this place, just you go what number it follows. Please go through it, which number it follows or what number it to be follows. So, if it is your the 7, if that number is more than 5, means here the 7, if it is greater than 5, for here it is the less than of the 5, and here it is the equals to your the 5. And if that one is your the greater than of your the 5, then the preceding one to be your the added. Preceding one to be your the added. So, here the third places will be here. If it to be or the round off, from here it to be or the round off, the followed is the 7, that is of the greater than 5. So, the preceding one to be or the increased, means this will be or the 2 point preceding one. So, preceding one is the which one, that is your the 3. So, that is equals to your the 4, means that is your the 2.34. 2.34, the 7 to be or the 4 to be or the rounded off, 4 to be the rounded off means it is your the less than of your the 5. For the less than of the 5, that will be your the 7. So, 2.3 means let us go for your the one of the example to that one. Suppose the you have to go up to your the 3 places, that is equals to your the 64 suppose that is the 64 point of the 62. 64 of the 62. We have to round up to your the 3 digits. So, for your the 3 digits. So, when we have to round up to your the 3 digits, so which one will be the 3 digits? So, the 6 will be the third one, that is 64 point here the 6. Then what it is follows? That followed here the 2. 2 means that is your the less than of the 5. It is your the less than of the 5. If it is the less than of the 5, then the number will remains here the unchanged. Means that will be here the 64 point of here the 6. Are you clear? As I had said earlier, if it is greater than of the 5, suppose that is the 64 point of here the 6-7. 64 point of the 6-7. You see the third places up to your the 6, then the followed one is your the 7. 7 is your the greater than of the 5. If it is greater than of 5, what I said? The preceding one to be your the added. The preceding one is your the 6. The 6 to be your the added with your the 1. So, if it will the added with your the 1, then what will happen? If it added with the 1, so that will be the added with the 1 means 64 point of your the 7. Suppose for your the less than of that one, that is the 3.651. 3.651. For the 3.651 rounded up to your the 3 digits, rounded up to 3 digits means that is equals to your the 5 will be the last one. So, what is the left? That is the 1. 1 is the less than of the 5. Less than of the 5 means it will remain as such. That is it here the 64 point of your the 6 5. Means it is the 3 point of the 4 5. 3 point of the 6 5. Are you clear to my students? Then it is a 546. Suppose another one 546.3. 546.3. So, less than up to your the 5 means the third rounded up figure is your the 6. 6 means after that is your the 3. 3 will be your the 3 is your the less than 5. For the less than 5, what will happen? The same one will remain. Means your the 546. The same one will be the remain. That is your the first rule. If it is your the less than of the 5, the rounded figure. If it is the greater than of the 5, suppose we will go for the greater than of the 5. For the greater than of the 5, what will happen? For the preceding one, you have to add 1. Means suppose 64.62, here instead of the 62, suppose I will say that is your the 7. So, it is the 64.6 means it is the third decimal places, that is your the 7. So, 7 it will be the rounded up means the earlier one to be your the added with your the 1. As per you know that suppose in your the big hotels, your bill counts your the 3397 point of your the 64 paise. 397.64 paise. So, if can you pay your the 0.64 paise instead of the 0.64, suppose it is your the 0.60 paise. Can you pay your the 0.60? No. So, at that case, that is the rounded off to this one, because this 0.60 is greater than of your the 50 paise, means it is greater than 50 paise means the previous one to be your added with your the 1. So, 397 will be the 398, and if that bill is count here the 397 point of here the 30 means it is the less than of the 50. So, what we discussed for the less than of the 55, the same one will be the remain, means it will be here the 397. Likewise, we are known nowadays we are using, but in your the case the most interesting one, if it is the equals to your the 5. So, for the equals to your the 5, what will happen? Let us now go for your the second one. The second one is your the, if the digit to be dropped is more than of the 5, means if it is the more than of the 5, then the preceding digit is raised by 1. Suppose 3.479 say 3.479. So, we have to round up to your the 3 digits. So, if we will round up to your the 3 digits means your the 7. The 7 is your the followed by your the which one? 9. 9 is what? Greater than of the 5. If it is greater than 5, then your the same one we have to add, means 3.48. Clear? Suppose 93 0.96, 93.96. What will happen for that one? 93 point here the 46, 93 point of the 46. What will happen for the three significant figures? 1, 2, 3. The left one is your the 6, which is the greater than of the 5, means 1 to be your the added. So 1 to be added means that is the 93 point of your the 5. Suppose it is the 683 point of the 7. What will happen? Up to the 3 rounded up. So up to the 3 means it is the this one. So after that, that is the 7. 7 is the greater than of the 5. If it is greater than of 5, 1 to be the added means 683 to be the added with the 1, that will be the 684. Are you clear to my students? If it is the greater than of your the 5. Next we will go for your the equals to the 5. So if the digit is dropped is 5 followed by your the digit other than of the 0, then the preceding digit is your the raised by your the 1. So the third one is, what is? If the digit to be dropped is 5 followed by your the other digits, means 3.65, suppose you will say 3, 3.653 I said. Suppose we want to drop at the position of the 5. Suppose it is dropped at the position of the 5. So after that, which numbers it has? If it has your the non-zero numbers or it has your the 0 numbers, then there are the two questions will arise. 3.653 means after 5 either 3 or 2, 1, 6, 7, 8, 9 like digits will be the present. If non-zeros are there, non-zeros are there, then implies the preceding one to be your the added with your the 1. Suppose this is the this case, means it is followed by your the 3. So 3.65 it will become your the 3.66. Suppose we will say 62 point of your the 354, 62.354. We have to round it up to your the 3 places. So up to your the 3 places we gone. So up to the 3 places, then what is the next one? Next one is your the 5. If the next one is the 5, the question comes, if it is less than 5 or if it is greater than 5, now it is the equals to your the 5. When it comes to your the equals to your the 5, there are the two things. Followed one is either your the greater than or non-zero, or it is your the other than your the 0 or the nothing will be there. Let us now discuss for your the non-zeros. Means it is the 62.354. So after 3, that is the 5, 5 followed with your the 4, then what will happen? If the non-zeros are there, the preceding to be the raised by your the 1, means its preceding to be the raised by your the 1 means that will be the 62 point what? Students, 62.4. Sir, how it is 62.4? You see 62.3, then it is the 5. 5 is the equals to 5. If it equals to 5, there are the two things. Either it is followed by your the non-zeros or it is followed by your the 0 or your the nothing will be there. Then we will discuss that one. So this one is for your the followed by your the non-zero. Suppose one is your the 9.6552. 9.6552. So for the 9.6552, what will happen? For the 3 digits, so we are going up to the 3 digits. After that, it to be the dropped. So if it to be the dropped here, then what is followed? That is your the 5. The 5 means it is only your the 5. There are the two questions. Either it is your the non-zero or your the 0. When the non-zero you see after 5, that is the 2, that is your the non-zero, then what will happen? Preceding to be the added, the preceding is the 9.65, so that is the 9.66. Are you clear? Suppose one is 589 point of your the 51. What will be for 1? We will go for your the 3 digits. After 3 digits, that is the 5, and the 5 followed with your the 1. 1 is your the non-zero. Then what will happen? The preceding to be the added. What is the preceding? 581. Added with the 1 means 589. This is for your the non-zeros. If it will have your the 0 or your the nothing will be there. Next we will go for your the 0 or your the nothing. For the 0 or the nothing, suppose 53.550. 53.550. Then what will happen? You are going for your the 3 significant figures. For the 3 significant figures up to this, then it is your the 5. Then 5 followed by your the 0. Means when it is followed by 0 or anything or your the nothing, followed by your the 0 or your the nothing, then what will happen? If the last remaining digit is increased by the 1, if it is the odd, but left it is if it is the even. Means after the 5, the last remaining digit is your the 0. So 0 means if it is the preceding is your the 5. 5 is what? That is your the odd one. If it is your the odd, then it will the mixed with your the 1, means added with the 1. So that will your the 53 point of your the 6. Are you clear? Suppose it is the 9.455, say 9.455. What will happen for this one? For the 3 significance up to this, 3 significance up to this, then it is your the 5. If it is the 5, the 2 questions, either it is your the non-zero or it has your the 0 or your the nothing. You see, after 5, nothing is there. So if the nothing will be your the there, then what will happen? If it has your the 0 or your the nothing, the last remaining digit will be increased. So will be increased means it has your the nothing. Last one is your the 5. It to be your the increase means that is the 9.46. Are you clear? Suppose one is 782 point of your the 5. 782 point of the 5. What will happen? 3 significant. Next one is your the 5. After 5, nothing is there. If the nothing is there, then what will happen? It to be your the remain to be your the as such, or it to be your the increased by your the 1. You see, after that it has your the nothing. Here also it has your the nothing. But the preceding was your the odd here. The preceding is your the even here. When the odd, it to be your the added with the 1. If it is the remain, it will remain. If it is your even, then it will remain as such. So that is your the 782. Are you clear, my students? It is the very important. After the third place, if it is the 5, means it is your the 5 means there are the 2 things, either non-zero or your the 0 or nothing. 0 or nothing. These 2 cases will come always. If it is your the non-zero one, then for that one you have to add 1 with its the preceding. If it is your the 0 or your the nothing, the 2 questions. If it has the previous is odd, then you have to add 1. If the previous is even, remain as such. Remain as such. These 2 you have to remember very clearly. So after completing the rounding of your the significant figures, we will go for it say the algebra. Means by taking your the significant figures, we will make the addition, subtraction, multiplication, division likewise. So next we will go for your the algebra of significant figures. Algebra of significant figures. So it has your the addition or subtraction. Addition or subtraction, it is the one type. Then multiplication and your the division. Multiplication and your the division. So for the addition and the subtraction, there will be a definite rule. For the multiplication and the division, there is a definite rule. So for the addition, suppose the two significant figures 2.314 is added with the 3.3. These are the two significant figures are given. So what is the rule? The addition result will take the least decimal place, of the provided data. This is your the rule which stands for it. Means the final result, the addition of the result will take the rounded of the addition result will take the rounded number of the least decimal places of the provided data. Suppose this is your the example. If we will add them, then this will be the 4, this one will be the 1, this 3 will be the 6, then 2 3 will be the 5. So if we will add likewise, then the final answer will be this one. Never, this is just the final answer. So what the final answer? The addition result, this is the addition result, will take the rounded number of the least decimal places. You see, these two are to be added. How many decimal places it has? It has the 3 decimal places. Please give the importance for this term, decimal places, not I am saying here the significant figures. So the 2.314 means 3 decimal places, here it is the 3 decimal places. So we will go for your the least decimal places, least decimal place is the this one, means you are the only one. So up to your the only one position we will go 5.6. But that to be your the rounded off. You see, means if we are go up to your the 5.6 means the first decimal, which is the followed, that is the 1. 1 is what? Is the less than of the 5. If the less than of the 5, it will remain as such. Suppose for your the answer 2.314 instead of this, suppose this is the 2.374. and it to be the added. So 4 4, this will be the 7, this will be the 6, 3 2 are the 5. So what will be the answer for this one, my students? The 3 decimal places it will go, means up to your the 5.6. Then it is the 7 greater than 1, means that will be your the 5.7. This is for your the addition. The similar process will go for your the subtraction. If you will subtract from this to this, then you will go for its the least decimal places. But for your the multiplication, suppose 2.1 and the 2.1 to be your the multiplied, then result will be the 4.41. Result will be 4.41. But here the rule is the result is rounded off taking least significant figures, taking the least significant figure. You see here how many significant figure? 2. Here how many significant figure? That is your the 2. So you have to take in the least significant figure, means the least one is your the 2. So you will go up to your the 2 significant figure. So you will go up to your the 2 significant figure, means your the 4.4. But then it is your the 1. 1 is the less than of the 5. So the result will be your the 4.4. But some students are making your the mistake here, means first they are making the rounded. Suppose for this case, for your the result of the rounding up, means they are rounding up for your the least places. For the least places it will be your the 3. So it will 3 means they will be making it is 2.4. So 2.4 mixed with the 3.3. It may come here the sometimes to be the correct, but for your addition it comes here the correct, but not for your the all times. Similarly you will go for your the division also. So this is your the algebra for your the addition, subtraction, multiplication and your the division. By taking this one, I am already given one question answer. 2.0 kilometer will be which one is the correct answer. Please go through that one and which one will be the correct answer. You think that one, then I will give him its answer. So students, we came to know about the significant figures, the rules for the addition, subtraction, multiplication, division, and for your the rounding up. And now I have given one question to you. 2.0 kilometer will be which one of this? Are you made it? So which one is the correct? Most of the students, they have followed the answer to be the fourth one. Let us now go for your the one by one. 2 kilometer, it is not your the 2000 meter, because 1 kilometer is the 1000 meter, 2 kilometer is 2000 meter. So this is the 2 into 10 to the power 3. 10 to the power 3 is your the 1000. So this is your the 2 into 1000 will be your the 2000, you will think. Then this is the 0.2 into 10 to the power of minus 4. That is also your the 2000, because 0.2 is the 2 by 10. This is 10 to the power of 4. So 2 into 10 to the power of 3. So 2 into 10 to the power of 3. Then you will say that that is also the correct answer. And all of the above means all are your the correct answers. But it is not. According to its the magnitudes it may, but it is in the question answer of your the significant figures. So one of the point or the one of the rule we discussed, when the unit to be the changed, the significant figures will not change its values. Means if it is in your the M case, it will switch over for your the CGS, then the significant figures will remain here the same. You see 2.0, how many significant figures it has? We already discussed. The 0 is coming after decimal. After decimal, the 0 which are coming, that is your the significant. So it has your the 2 significant figures. This has your the 2 significant figures. Means in all the answers you have to find that it has its the 2 significant figures. For your the 2000, how many significant figures it will have? Only 1, because the zeros are at the ending position but not followed with your the decimal. So it has your the only 1 significant figure. For this one, 2.0 into 10 to the power 3. You see 10 to the power 3 is the another rule in which we have said the power of the magnitudes are your the non-significant. Means this is the power of the magnitude. It has your the no significant, and 2.0 it has your the 2 significant. So the 2 significant figures. For this one, 0.2 into 10 to the power of 4. 10 to the power of 4 again is your the power of your the magnitude. It has your the no significant figure. Only your the 0.2. This is only 1 non-zero. So it has your the 1 significant figure. The question is, this kilometer to be your the meter means kilometer to your meter means the unit is changing and it's the significant figure to be the same. So which one has the same significant figure? It has your the 2 significant, it has your the 2 significant. So 2 into 10 to the power of 3 meter is your the correct answer. So those who have opted for your the double I means they have the Rasika Aja, that double I answer is the correct. Okay, my students. So this is all about your the significant figure. It's the rounding up for addition, subtraction, multiplication, and your the division. If you have any doubt and you will get it in your the YouTube, you make your the comment, then I am always there to give you the answer. Next we will go for its the error analysis. Error analysis. So this word error is the very familiar to us, but there are the two terms I will say. One is the error, another one is your the wrong. Error and the wrong. Can you agree that the error are your the will be your the wrong, or the wrong and the error to be your the different? Both are to be your the different. This error it will takes when the measuring value is approaching towards its the true value. But this will be, or the wrong will be that one when it is far away from that one, means there is a great difference to be or the occur. So this error means whenever the every measurement which are going on, there is a proverb, every human being has an error. Every human being has an error. It is the correct. Means it is going on steadily, no doubt. But at any step, there will be the chance of the error, means he or the she may go away from its the track. If it is going it starts to go from away its the track, at that case we will say that the errors are the arising. If we will go far away from that one, we will say that he is or the she is completely away from its the line, and that is the wrong. His life becomes the wrong, we will say. So the error is the what? Means every measurement must have the error, and this error is nothing but the difference between the actual value or the true value with the measured value, with the measured value. There are the two things, actual value and the true value, or the true value with its the measured value. Means what was its value, but what we are measured, if there is a difference, then that difference, if it is very negligible one, then that is called here the error, and if that difference is your the much more, then we will say that is your the wrong. Suppose one measurement is your the 3.5 centimeter, and someone counted it as 3.51 centimeter, but someone said it is your the 5.51 centimeter. Suppose this is for your the measuring of the A, this is the measuring of the B, and this is its the true value, not your the Doordarshan TV. This is your the true value or your the actual value. So what is the difference between these two? Only your the 0.01. And what is the difference between these two? That is the 2.01. You see, 0.01 and 2.01. This is the true with this one. If we subtract, then this is the 3.51 minus 3.5, 0.01. 5.51 minus 3.51, that will give you the 3.5 is the true one, 3.5. So 3.5 means that is your the 2 of the 3, that means your the 2 point this one. Okay, correct. So this is your the much greater difference. Therefore we will say that this measurement done by your the B, it is your the wrong, and which is done by your the A, it is not your the correct, but it is approaching to that one, so that can be your the accepted. For the error, if it is the very smaller one, then that is accepted. Not only in your the plus way, but also in your the negative way also. Means in your the plus 0.01 or the minus 0.01, that is your the accepted. So that is the error, and this is one. But the question is here, sir, what we measure, that is called the measure value. Sir, how will you come to know which one is the actual value? So that actual value must be your the measured, means that is also your the measured value. So how will you find the actual value? Let us give me one of the example. Suppose you are in your the college. Suppose a new face you seen, either that is a boy or your the girl. If I will say the girl, then you will be give your the most attention. Suppose a new girl enter to your the college premises. You the four what your the friends, you just look her. Then after she pass away, you just analyze yourself. One will say that her face is likewise, her eye is likewise, and her figure is likewise, and her height is likewise. So different ones are given your the different directions. So what will be the actual figure? you take someone's of the eyes figure, someone's of the height distance, someone of your the weights, and if you will taken all together, then we will say that this figure will looks like to her. So, instead of the 4 friends, if the 6 friends are there, then the 6 friends will give the 6 different observations about to that one. Hence, to find the actual value of your the any physical quantities measurement, it gives the different calculations or the different measurements if you will take, then the accuracy of that measurement will be the more. Means if there is an element of your the length of your the x, so length of the x, and that is measured by your the different students like your the x1, x2, x3. Suppose we will take up to your the n, so that is up to your the n. So n measurements are the done. So when all these n measurements are taken to be the together, then that will give you its the real or the true value. So the true value will be x1 plus x2 up to plus xn by your the n. So when the things to be the added and with the same numbers to be the divided, in other way that is saying it's the mean value, means if you take the mean of all that observations, then that will give it's the true value. So this true value or it's the mean value, that is your the mean value of which one for your the x. So you can say this is your the xm, means the mean or your the x. So x will be your the this one. So for the x will be the this one, means out of them someone are very approaching towards or someone to be or the living to that one. So then you have to calculate its the absolute value, or it is your the absolute error. Absolute error. So that absolute error, it is the difference between of your the actual value with its the measured values. That is it's the actual or the absolute errors you will have. Means if you have the true value of your the x, then there is a absolute. Absolute is your the some difference, that is equals to your the delta x. For your the first observations, we will give you the difference between the true value. You see the true value is your the x with its the first measurement, say that is equals to of your the x1, and then delta x2 is equals to x minus of the second measurement, that is equals to x2, and likewise if we will go for the delta xn, then x minus of your the xn. So these are its the absolute values. If we will take some example of that one, then this delta x1, delta x2, delta x3, it may be your the positive or the negative. So the absolute value or the absolute errors, it may your the positive or your the may your the negative. So let us now go for its the error measurement. So what is the error measurement? It is the difference between the actual value of the quantity and your the value obtained by your the measurement is called is your the error. And that error is of the 3 types. One is called your the systematic error, gross error, and the random error. Systematic error, and it is of your the 3 types. One is your the systematic. One is your the gross. One is your the random. So the error is divided into the 3 types: systematic error, gross error, and the random error. The systematic error means the cause we know. Error means it has your the some difference between its the true value and its the actual value. So that cause we know means that can be your the removable. But for your the random error, we do not know where that error being your the arises. So to avoid that one, we have to take in more observation for its the accuracy. So the systematic error, these errors arise due to the flaws in the experimental system. The experiment which we are taking, there are the some lacuna is going on. Therefore, some error is the arising. The systems involves the observer, the measuring instrument, and the environment. The three things. Whenever some measurement is going on or some measuring quantity is going on, there are the three things are there. One thing is your the observer who is there, another one is the measuring instrument, and the third one is the environment. These errors are eliminated by detecting the source of the error, because though we know it's the cause, this can be the detected out by knowing it's the cause. Next one we will go for the systematic error is of here the three types. One is due to your the personal error, because here we said there are the three ones. One is your the person, one is your the instrument, another one is the environment. One is your the environment. So due to the persons, the error will arise. Due to the instrument, the error will arise. Due to the environment, the error will be the arise. And what are the examples for that one? Suppose for your the personal error, these errors are arise due to the faulty procedures adopted by the persons making the measurement. Means you frequently have that things. Suppose there is a scale. Suppose you have a scale. You have a scale. Suppose this is the scale, and some measurement is going on. Suppose this is the 1, 2, 3, 4, and something is measured up to your the 1. And if we look for the different angles, then it may take your the 1.1, or it also looks here the 0.9, or it also looks here the 1.1. But actually the length is taken up to your the 1 centimeter. Instead of that, you may take here the 0.9 or the 1.1. As per in your the figure, it also here the same type of the example. Suppose some parallel error is here the there, and there are the three measurements are going on. So if we look for it, see the scale range, the middle one, which is 4.8 centimeter, that is it's here the correct answer. That is your the personal error. One is it's the instrumental error. In case of the instrumental error, one of the example, suppose you have a tape in which we are measuring the length. So of that tape which is frequently used, suppose it's the one end being your the cut at. So if there is no one end, suppose it is started from the 0, but up to this it being your the already taken out, or it being your the lost. Means this one not your the 0, this is your the 0.2 position. Suppose the length is your the up to your the 40 centimeters, say, up to your the 40 centimeter. So if it is placed on your the particular level, then what will you say the total length? You will say, on looking your the final one, you will say it is your the 40 centimeter. But you see on its the initial stage, the 0 is not there, means it is started from your the 0.2. So instead of the 40 centimeter, the real length will be here 98.39 point of your the 8 centimeter. So that is your the due to this instrument, means the tape which we are used. So that is your the one of your the instrumental error. Next for your the environmental error. So for the environmental error, what will happen? The environment have the pressure, temperature. If the pressure, temperature to be or the vary, according to that the instrument will the vary. So my dear students, you know that if some valuable instruments are there, like example of your MRI, suppose of your the ECG, or your the big computers are there, and where they being placed of that situations, they are controlled. It's the temperature and the pressure. And if that temperature and the pressure will not be the control, then the result which you will get from that of the instrument, that will not be the correct. So that is your the instrumental of the errors. So you see in your the figure, some advanced instruments are placed in your the some rooms, and that rooms are to be the controlled with the environmental conditions. And if the environmental conditions will vary, then that instruments will not provide the accurate values. Next comes your the gross error. So these errors are caused by the mistake in using the instruments, recording data and the calculating the result. Suppose a person may read a pressure gauge indicating 1.01 Pascal as your the 1.10 Pascal. By mistake, a person will make an ordinary electronic scale having your the poor sensitivity to measure for your the very low masses. So these are it's the gross errors. One is it's the random errors. So these errors are due to your the unknown causes. As I said, for the random error, we do not know it's the cause, means we do not know the cause due to which it happens, and are sometimes termed as your the chance errors. These random errors is also called as your the chance error. This is your the, we do not know why it being your the happens, and to avoid that one, we have to make your the more accuracy, and they can be reduced by taking your the more statistical operations, and that is your known as your the random error. So the errors are coming. Suppose for your the example, you measure the oscillation of your the some stopwatch. On your the screen, the time trials are the given and the measure values are given. We tried for your the 5 times, and the measure values are the likewise. So in the different times, we are having your the different time interval. In the first one, we are getting your the 3.9 seconds, and for the second trial, it is a 3.5. Means this is it's the error are coming. Then comes it's the mean error. The average of all the errors which to be taken into account, that is called it's the mean error. Then comes it's the absolute error, as we have discussed earlier. Absolute error means it is the magnitude of the difference between your the mean value and of the each individual value is called here the absolute error. So for the absolute error, ABSOLUTE, absolute error. So that absolute error is always expressed as your the del x, means there is a change between your the, this is it's the mean value, we have taken x with it's the each of the observed values. So when this observed value is less than of the mean, then this is your the positive. When this observed value is more than of this, then it will be your the negative. So if you will take it's the average one, the average of absolute error. So average of absolute error, that generally is written as your the del x, if that is equals to del x1 mod plus del x2 mod plus likewise how many numbers we have taken. Suppose this is the del x10, then you have to divide it by your the 10. This is called your the average absolute error or your the mean absolute error. Mean absolute error, that is in some books that is your the del x, in some books also you will find that is your the del x bar. Then is your the relative error. Relative error. This relative error or fractional error or fractional error. For the fractional error, that is equals to del x by your the x. Del x is your the mean absolute error with its the mean value, with its the mean value, that is known as the relative error or your the fractional error, and when it is multiplied by your the 100, that is your the percentage of error, percentage of error. So these are the different classifications of your the error. We first came to know what is the error and in how many types it to be the classified. One is it's the absolute error, next we will find it's the mean absolute error, then it is the relative error or your the fractional error, next is your the percentage of error. By taking all these errors into account, we will next consider about your the propagation of the error and keep study about this one and make some calculations if you have in your the books. On your the next class we will discuss vividly about that one. Thank you very much to my students.